Hi, welcome to the OAR Proof of Concept demonstration video, or Opioid Addiction Resources Proof of Concept. My name is Chris Emmett. I'm a student in the IT 700 Capstone in Information Technology under the guidance of Dr. Raymond Kurtz. This is a video demonstrating the project that I created, and let's get started. So what we're going to go over today is the problem statement for the project to give you some background on why the project was created and some of the needs it's going to meet. After that, we're going to cover explanation of geospatial functionality. Then we'll take a look at the Amazon Web Services database that we created, just to show that we were able to deploy this into the cloud, which was satisfies using some of the emergent technologies that was part of the project requirements. We'll take a quick look at the stored procedure run within one of the SQL tools, and then we'll show the functionality within the Tableau Dashboards to actually really demonstrate the power of the geospatial database and the ability to show things graphically. So the POC's problem statement, in searching around in this project, I found that a lot of the current portals that are out there for finding opioid addiction resources are not really comprehensive. You have to search through several different ones. So if you go to the federal one, you can actually search by location, latitude and longitude, or a zip code, but the results didn't include everything. You might get some doctors, you might get some addiction resource centers, but you wouldn't see everything. They also, the portals aren't really keeping up with resources that are being offered. Case in point, within New Hampshire, there's a program to make Narcan available without a prescription, and there's several places, including CVS pharmacies, some state clinics, that actually you can go and get a Narcan kit. And you couldn't find this in any of the federal portals or even the state PDF that was offered. The other issue with these portals for this type of information is they're not really open to allowing other applications and apps or websites to actually integrate and use them. You really have to go down to the sites themselves, and if you were to look at them on mobile phones, they're not very friendly, especially if you were looking at the state listing, which is in a PDF format and is over 50 pages long. The other thing is that only some of them allow for searches by location, while others do not, case in point being the PDFs. So out of this, I came up with the OAR proof of concept to address these shortcomings. So what this particular, the overall project was envisioned to be a geospatial enabled database that would allow you to view or pull back resources based off of a location, either through an address or a latitude and longitude. Along with that, they were going to be built some web services, and those would be exposed to the public. However, given the short time period of the course, the web services were deferred and stored procedures were created. The database contains not only resources that are available in the federal and the state portals, but also some of the new non-traditional resources that are starting to emerge, such as the Narcan kits, and specifically within the city of Manchester, New Hampshire, the Safe Station projects, where anyone who needs help with opioid addiction can go to a fire station without the fear of being thrown in jail or anything, and the fire department will help them get them into a treatment program. The other thing is it's hosted in the cloud, so the actual database, the production version of it, has been deployed onto an AWS PostGIS instance. So that allows for anyone to develop against it. and it's completely searchable by latitude and longitudes or addresses. So you can get any of the locations within this particular database by entering a latitude or longitude, a latitude and a longitude, or an address. You can also filter for the certain types of what I've called providers. If you're thinking about a provider, it's either a medical doctor, a psychologist that specializes in addiction, medical centers, rehab clinics, and some of the other non-traditionals that I mentioned earlier. So let's take a quick overview of what geospatial functionality is, because it's really kind of important to understand that to realize what this project is using to actually return results. So within Postgres, there's an extension known as PostGIS. It allows the database to be geospatial enabled. So in other words, you can actually search for locations by geographical or spatial reference systems data. You can store the data in a geographical manner, and the way that it ends up doing this is it's really just mathematically projected geographic maps or spatial reference systems. If you think about a map of the United States, what it ends up doing is these algorithms which are geared towards a particular reference system will actually return values that are unique to the location within that spatial reference system. These algorithms actually generate shapes such as polygons, lines, so if you think about roads, borders, and they also generate points so that you can actually pinpoint locations. Not only do the spatial reference systems allow you to project these points and polygons and everything, but they also allow you to find out the distance between them. And this becomes very important as we're using a radius to find out what locations are around or providers are around a particular location that's been entered. So given that, let's take a quick look at one of the tables to help explain the geospatial functionality a little bit better. So as you can see here, I have two databases. One is a local instance, which is just hosted on my laptop, but I also have the AWS instance, and this is the address to it out there in the cloud, and it connects up quite nicely. So if you wanted to take a look back and see the properties of this, here's the actual host endpoint. The point's the same, and then the username is entered down here along with the password. So you get a couple of defaults here within the AWS offering of Postgres. Of course, you get public. It always kind of comes along, but then you're always going to get a Postgres database and an RDS admin, which is the relational data store that offering from Amazon Web Services. So I created this AOR database. Within that, there's a particular schema where I do most of the work. There's some other schemas that were added, which is Tiger, which is loaded with U.S. Census Bureau data that allows for addresses to be geocoded into latitudes and longitudes, and we'll see some of that functionality later. So what I'm going to show next is the provider table. The database, which is in the OAR OSP DB schema, was designed with the star schema. The provider table is at the center, and all of these others such as address, provider address, provider contract, meeting schedule, and so on are all satellites of this. The provider table is the one that brings them all together, but most importantly it stores the geospatial reference data. So if you take a look here at the definition of the table, you've got this one particular column called location geopoint or locin geopoint, and it's a geometry type, and the type of geometry is a point, and then there's a number that comes after it, which is 4326, and that's actually an SRID or spatial reference identification. And the 4326 SRID is specific to the GPS system used by satellites, so it expresses everything in the spatial reference systems in latitude and longitudes. So if we take a look at the data, we'll look at this real quick. Here we go, sorry. And we'll look at all data here. And what will pop up is, what we have. We have an ID, the type, and then you have the latitude and longitudes. And so then essentially what we did is we used a function to create a geometric point from the latitudes and longitudes, and then it gets stored out in this type of format. Doesn't look pretty, but the PostGIS functionality actually uses this to actually plot these within the algorithms so that it can find the particular locations. Let's take a look at the function so we can kind of talk about how this data is created and how it's used. So if we go over to GitHub, we've got the function of meeting by latitude longitude type option. Essentially what this ends up doing is allows you to enter in a radius, a latitude, and a longitude, and then you have an option to enter and to filter for a particular type. So if you're looking for a particular type of support meeting, you can enter that in, or you don't have to. We'll come down to the bottom here, and if you look at the top part here, both of these queries are essentially the same. The only difference is one's filtering for a particular type or one doesn't. But the important part in the where clause is this right here. This is where the engine of the geospatial reference systems gets kicked into gear for the project. So essentially there's two parts to this, and I'm going to start with the inner part here, which is this right here. And so I've put down a little explanation here. This is a particular function that allows you, from well-known text, which is what WKTX, create a geometric shape of your choosing. The first input to the function is the SRID, so it's important that if you want to use geometries that are created in the same SRID, else you're going to get errors or things are going to look funny because different spatial reference systems plot things in different ways. So you want to make sure that you're using the same SRID as what you have in other areas of your application. You're going to choose your geometry type. In this case we chose a point, and then you're going to input a longitude and a latitude. And it's important to understand that it's going to be the order of longitude and latitude. Most everybody, including Google Maps, likes to list things in a latitude longitude order because it's alphabetical. But when it comes to computer science, and if you think about back to graphs and grids, you want to list things in an XY coordinate. Well, for the X coordinate it's the longitude, and the Y coordinate it's the latitude. And so you see up here we have this _p long and _p latitude. Those are parameters that come in from calling the particular stored procedure. So this part of this particular function gets so we've got two functions nested in each other, and this one goes first, and it actually creates something like the point that we showed in the provider table. The next part then goes to the outer part of the function, and we're using this st within. So what this actually does is it searches for locations based off of a radius, and the radius is the center of the point that you feed to it. So when we create this particular point, we're creating the center of the radius. So we create the center of the radius. Then the next one is, okay, what points are you going to search that are going to be within that radius. So in this case we have this meeting geopoint. The meeting geopoint actually corresponds back to the provider table and that locum geopoint. This is just projected from the meeting provider view that calls on that table. And then you also put in a radius, and the radius is in meters. Well, that's a bad misspelling, sorry about that. So there's another function that I've created that we actually call, and if you put in miles, this particular function will return something in meters. So that's really kind of an overview of the geospatial bit. So what you end up happening here is when the point gets put into this outer function, it searches all of the points within the provider table and sees if they're within the given radius. We'll take a look at how that actually works, but we're going to switch over real quick to show that we have this running out in the AWS cloud. So here we are at Amazon Web Services, so we're going to sign into the console to take a look at the PostGIS instance we have running out there. Come in here, and there are a number of offerings within AWS. At one point I was experimenting with a Unix cloud server, which they refer to as EC2. There's a multitude of services you can actually look at here. You can even get into what they call the Redshift, which is a big data platform. Lots of great things. They work with a lot of different vendors. It's definitely worth exploring. So if we go back to the RDS offering here, we can take a look at what instances we have running. So if you can see right here, we've got 1 DB instance, and there's a number of different databases you can run on AWS RDS. Of course, PostGIS, MySQL, and MariaDB, to name a few. So we're going to go ahead and look at this, and if you notice here, here's this one PostGIS instance. It's our PostGIS OAR DB. And here's our endpoint, and looks exactly like what we've got going on up here for what we connected to earlier. If we come back into this, we can get a little bit more details. They do some automatic backup. That's some nice features here. You can see how much memory and storage you've got. We're looking at 3,500 megabytes. Bunch of different things. You can look at what's been going on in your I/O, and your read and your writes. And then you can get down into this. This is more some of the more interesting information as far as what your groups are, subnets, and then more importantly is the security groups. Here's your endpoint again, the port. I want to show you the security groups here, because this is essentially a firewall that's built automatically around your database instance. So here we have this particular firewall for the RDS, and if we come down to inbound and click on edit, we can actually see the rules we've set up here. So these are 2 IP addresses where I've been able to access the database from, one locally and one remotely. If you were trying to actually connect to this database from anywhere outside of these IPs, you would be blocked. The idea here for the overall project is that we would likely only open this up to some administrators and then whatever eventual web services that we built. So that's really the great thing about the AWS there. There's a lot of things that are done for you. You don't have to worry about the hosting on any of the hardware. You don't even have to worry about installing the PostGIS database. That's pretty much done for you. You choose which version you want, and then the AWS has a number of guides for adding extensions. It was
probably the most comprehensive I saw in adding the PostGIS
PostGIS extension. So there we have our AWS. So let's move back and let's show some of the actual running of the stored procedures that we have. So we'll close down this window here, come in, and we can launch a SQL window. So essentially the pgadmin is an open source tool that is probably one of the better tools to use with Postgres. I find it really easy to use. It's on par with things like DB Visualizer or any of the other proprietary offerings, and I certainly like it better than the one that used to ship with Oracle. We've got some test calls here for the stored procedures that we've created, so I just wanted to quickly show those before we started showing how the data gets displayed in maps in the dashboards. So the first one here is a function provider with option type. So essentially what this is this is just a stored procedure that calls and returns all providers within the particular database. So you can quickly run that, and here you get it calls that, and you'll see everything here. You've got the IDs, but if there's a provider org name for the doctors, we didn't list any provider org names because the doctors are actually those providers. Phone numbers, addresses, secondary lines, third lines, city, state, and zip codes, just your basic information here. And of course the latitude and longitude and geospatial points. You have your medical doctors, you've got the safe station, fire stations within Manchester, we'll look at those, and a number of different other healthcare providers that help in addiction resources. This is kind of boring, really. This is everything that's within the database, 126 rows, mostly centered around the New Hampshire Seacoast area, Rochester where I live, and within Manchester. But this just kind of shows you that we can actually pull everything back. We didn't actually put this in a dashboard because it's very unlikely that somebody would really want to look at every single location in the database, especially if we were to blow it out to a more regional or national level. So then we can also show here some of the interesting things we end up doing. We can actually look at particular providers within this. So the same function can be called, and you can give it a set of these types. So a doctor, a self-help meeting, and the safe stations within Manchester. So we can do that, and of course this is all running in the cloud. It's pretty quick, as you can see. There's not a lot of latency, but here's all your doctors, your safe stations, and some of the clinics that come back with meetings. All great. Again, this actually is a little bit better than showing everything. You can see everything, but again, if you're looking at a regional or national database, it's going to be a very long list. So the real power comes in when you're able to actually use some of the geospatial functions. We're going to not search for a type in this, just to kind of show what ends up happening. So if you look at this latitude and longitude that we've entered here is my house, and we're going to look for providers within a 10-mile radius. So if we go ahead and run this particular function with these inputs, there you go. So here you go. I live in Rochester, and the surrounding towns are Somersworth, Farmington, and Dover. And these are all the particular providers listed in the database that return back results. So we're essentially, again, we're converting this latitude and longitude into a geospatial point. Then there's a radius applied to it, and then the function searches all of the providers in the provider table by that locin geo point data type, and sees if it falls within that particular radius. Pretty cool. But really when it comes into its own is when you can see this in a graphic type of manner. So what we're going to do is we're going to come into Tableau here, and we created several different dashboards to actually show some of the functionality here. We've created 4 total: providers by latitude and longitude, providers by address, meetings by latitude and longitude, and meetings by address. Like I said, we did have the ones that return all results, but it wasn't as exciting. You know, it's like, okay, great, you returned all results. These are a little bit more interactive. You can play around with the parameters and whatnot. So let's get started with the providers by latitude. So we're going to connect to our AWS database. So we got to enter in the password first thing. So let's try that again. Sometimes I enter the password wrong. There we go. So first off, you make a data sheet or a data source. Most of the time in Tableau you're working with Excel, but you can actually connect to a database, which we've done here, and you can take a look at the custom query. And within the custom query, it's just like we were doing before, but you'll notice that we've got parameters in place of actual values. So we've got a radius, a latitude, and a longitude parameter. We can go ahead and have this update automatically, and here we go. It pulls back essentially what we were looking at before. So if we go over to the dashboard, here's where the real power comes in. You start to see the locations plotted within a map, and down below we've actually created a listing here of all the different locations that are available. And you can click on these and see some of the tooltips and get where, like, what the phone number of the location is, what the address is. Here's a CVS pharmacy that provides Narcan with prescription. You can scroll down through here and see all the different providers that are around. But what's great is this dashboard is completely interactive, and the connection to the database is live. So we can actually expand this to a 25-mile radius. Put my number locks on. Hit enter, and boom! It automatically updates, and you can start to see a larger radius of what's going on here. It's great. The one drawback to Tableau is being able to see the actual listings out here. They treat these more as labels, but it was good still for the purposes of this demonstration to show what we've actually got going on. You'll notice that we're not actually in the query passing any kind of types, and the reason being for that is Tableau's not dynamic when passing types back and forth. Really it has to do with the data type of the types. We actually pass an array value, and Tableau can't do that, but what Tableau can do is filter results locally. So it still runs and pulls back everything, and then it ends up filtering locally. And this is kind of indicative of any business intelligence tool. It allows you to slice and dice in the tool itself. So as we start eliminating some of these types, we get down to fewer and fewer, and then we get none. It comes back. We get all of the support groups. And go back to all. So that's our providers by latitude and longitude. There's another one here that we can open, which is providers by address, and this one is pretty powerful because frankly, how many times are you going to know what your latitude and longitude unless you're a smartphone app that can get that information? So if you were actually on a website, you'd probably enter in your own address. So let's go ahead and connect to the database on this one. Let's try one more time. There we go. Essentially, we've got a calling the by address top option, and we've only got two parameters here. We've got a radius and an address, and really what this particular function is doing, and I think I have one of these up and ready to show, is if we think back to the other one, what ends up happening is we make a call before actually passing in the latitude and longitude, because we don't have that. So the first thing is we call this GeoCoder function, give it the address, and then ask out of that function to actually set the longitude and latitude to the X and Y coordinates that are coming out of that. And then do a nice little trick, and instead of like recoding everything from scratch and essentially duplicating the view call in the provider by lat long, we just called the provider by lat long and give it the lat and long that come out of this particular call to the GeoCoder function down below. So back to the Tableau, take a look at the dashboard. Essentially, we've got the same thing. On this one, I've actually entered in the address for SNHU, and if we click on that, you can see all the different areas around there. Some of the more interesting stuff, if we look at the safe stations, these are basically all the different fire stations. Whoops, I'm sorry. These are all the fire stations within Manchester that people can go to go and get addiction help. Again, we've got like some medical facilities for support groups, and we have Narcan, and we actually have a radius here all the way up to Concord. Again, we could actually expand this out to 50. And now you start to see a lot of different things, a lot of things clustered around Portsmouth and the Dover area, what we call the Tri-City area in Manchester, and everything's listed down below here. There's two more dashboards I want to show you. They do essentially provide the same functionality, except these were geared more towards showing meeting information. So we'll go ahead and open those up. So if we go meetings by lat long, sometimes it takes twice to get into this. Again, same type of function call parameters. If we look at the dashboard here, again, we're looking around for meetings within Rochester being the central point. So here we have Narcotics Anonymous type meetings all over the place. There's another one which is DRA. And if you look down here, these are just basically the locations and the meeting types, because sometimes you'll have more than one meeting taking place at the same location, and so what we've ended up doing here is showing down below the day and the time that the meeting takes place. If there's any other kind of details around the meeting, like within the Notre Dame Spiritual Center, Dennis Hall is where the meetings are held. There's one on Tuesday at 7, Thursday 7 p.m. and 8 p.m. Just a bunch of different things. Essentially the same type of functionality that we saw before in the other dashboards, where we've got we can expand and change the parameters. Let's take a look at the last dashboard, which is meetings by address. Yes. And here we are. Again, just like the by providers, just a radius and an address. And we'll go down to the dashboard, and you can see here on this one I have my address. But just to prove that it's live, let's switch the address up. So if we come back over to this one, we can grab the one for SNHU, and then we can go ahead and that full address, just to show you real quick, is 2500 North Riverside Road, Hooksett, New Hampshire. So we can go ahead and we'll close out of this one and back to meetings by address. And again, dynamically changes, calls out to the database, brings back the data. So there you have it. That is the opioid addiction resources proof of concept. Just a small database to show the geospatial functionality that can happen, and how essentially if we were to build out a website or a mobile application, how we might display the data. Really enjoyed building this project. It was great to get into the geospatial aspect of it and learn a little bit more than what I knew, than just what I had scratched the surface before. And it was also good to actually get into the dashboards here and learn a little bit more about Tableau. So thank you for watching, and we'll see you later.